This video has been created by Great IT Courses. It's a part of a mathematics course that will teach you mathematics step by step from basic algebra all the way up to calculus. For more information or subscribe to the course, please read the video description. Thank you. So in this video we want to talk about the PointSlope Form formula. Now first of all, let me tell you what I mean by PointSlope Form. Basically, the PointSlope Form is a formula of a form of a formula of a line or equation of a line that where you identify basically one point on the line and also the slope of the line, and the equation is basically y minus y1 is equal to m into x minus x1. That is the PointSlope Form formula. That means that you have in this equation y and x basically are y and x, any y and x on the line, and x1 y1 is just any point that you actually know on the line, For example, you know that, for example, the point 2 comma 3 is on the line, and m is the slope of the line. You know that already as well. So you have these two pieces of information. If you have these two, for example, you know that your m is equal to 2, and you know that the point 2 comma 3 is on the line, and then you want to figure out what the equation of the line is. So based on all of this, you can simply say that, okay, so I could write y minus y1, which is 3, is equal to m, which is 2 into x minus x1, x minus, for example, 2. This is your x1. And then you could simplify this. You could write this as y minus 3 is equal to 2x minus 4. And then you could write this as y is equal to 2x. This goes to the other side, becomes plus 3. So minus 4 plus 3 is equal to minus 1. And this is basically the equation of your line. Now you might be asking, so how we got this equation? This is actually a very simple relationship between any 2 points on your line, and it's essentially just simply the slope of your line. Let me tell you what I mean by that. If you have this line over the Cartesian coordinate system over here, and let's say you have a line like this. So this is your line, and this is your x-axis, this is your y-axis. Now if you know any such point on this line, like this one, let's call this, for example, point, the coordinates of this point are x1 and y1, and you could identify an infinite number of points on this line that have the coordinates x comma y. Basically any point that you can find on this line does have the coordinates x comma y. So we said that basically, let me erase all of this. We said that basically the slope of your line is basically the rise over run. So in this case, your rise is this length on the y-axis. So this is your rise, and your run is basically from here to here, something like this. So this is your run. So this is your run, this is your rise. Now if you divide your rise over your run, that basically is the slope of the line, which is denoted by m. What I probably haven't tell you yet is that we denote basically rise. We said that we write our rise as y2 minus y1. That means that we basically identify 2 points on the line. We call them, one of them for example point 1, and we call the other one point 2, and then the y coordinate of the point 2 becomes y2, the y coordinate of point 1 becomes y1, and then you write y2 minus y1 as your rise, because let's say this is your point 1, this is your point 2, and then you compare basically the y coordinate of this point to the y coordinate of this point, and you write it like this. And you can write this as, by the way, as delta of y. In mathematics, any sort of change could be denoted by delta. For example, y2 minus y1, or any other sort of change. And then you need to divide this by the run, which is basically the change in x, which is x2 minus x1, and you can denote this by delta x as well. So this is something that you just need to be familiar with. It's not that important here. Now in this specific case, I have basically x1 y1, and I have x and y. I've called this x and y because I meant a general case with that, because I didn't know what the value of that was. But I've called this x1 y1 because I do know the value of them. So in this specific case, I could rewrite this whole thing as let's call this point, for example, point 2, let's call it point 1, and so based on that I can write y minus y1 over x minus x1. This is equal to the slope of your line, because if this point is on, if this point x and y is on the line, and if this point x1 comma y1 is also on the line, then if you compare the x and y components of the 2 points, that must be equal to the slope of the line, because that's basically the definition of the slope of your line. So now you can cross multiply this. You can write this as y minus y1 is equal to m into, you could think of this as m divided by 1. So you multiply this whole expression into 1, and you multiply this m into this whole expression in the denominator. So you write this as m into x minus x1, and that's it. That's the formula that we came up with, that we basically introduced in the beginning of this lecture. So y minus y1 is equal to m into x minus x1. That is called basically the point slope form formula, and that's basically, that's nothing but the simple relationship that is nothing but the simple relationship there is between any 2 points on any line. So that's how we got this formula. And from now on, you can use this formula to find the equation of any line if you have just one point on the line, if you know any one point on the line, and if you know the slope of the line. So we still have some time here, so let's do one example to get some idea of how we can deal with this kind of problems. So this is number 23-1, and let's do an example here. Find the equation of a line given the slope and 1 point. Example number 10. Write the equation of the line with slope with the slope m is equal to -3, and passing through the points the point 4, 8. So this is the slope of the line. This is just one point on the line. Write the final equation in slope-intercept form. So we said that y minus y1 is equal to m into x minus x1, and please know that we are supposed to write the final equation in slope intercept form. So the slope intercept form. Now so here you can simply substitute. You can write this as y minus y1 is 8 is equal to -3 as m into x minus x1, which is 4. But this is not the slope intercept form. Let me see what we had here. This is basically the point slope form. As you can see here, I have here basically the x1 and y1 over here. So this is 1 point, and this is the slope of the form. So we call this form the point slope form. Now the slope intercept form is basically y is equal to mx plus b, and that's called the point intercept form because that's called the slope intercept form because here you can simply see the slope of the line, and here you can see the y-intercept of the line. But we'll get to that later once we're done with this. Now you can simplify this. You can write this as y minus 8 is equal to minus 3x plus 12. So y is equal to minus 3x. This goes to the other side and becomes plus 8, and so 12 plus 8 is equal to 20. And so this is automatically y is in the form y is equal to mx plus b, and so this is your slope, and this is your y-intercept. And so this is the equation of the line, minus 3x plus 20. And let's do another one of these. So I have 4 minutes here. So let's do another one of these. So this is example number 8. It says given m is equal to 4 and given m is equal to 4, find the equation of the line in slope-intercept form passing through the point 2 comma 5. Passing through the point 2 comma 5, and find it in the slope intercept form. Now in order to find that, you need to first write the formula y minus y1 is equal to m into x minus x1. Your y minus y1 is equal to 5, m is 4, x minus x1 is equal to 2, so y minus 5 is equal to 4x minus 8, so y is equal to 4x minus 8. This 5 goes to the other side, becomes plus 5, so plus 5 minus 8 plus 5 is equal to minus 3, and this is the slope intercept form of the line. And here is your, this minus 4 is the slope of the line. This minus 3 is basically the y-intercept of the line. The y-intercept of the line, and then that means that minus 3 is the y-intercept of the line. That means that your line cuts the y-axis at the point minus 3 on the y-axis. That's that. So I think we're done with this video. So thank you for your attention, and I'll see you in the next video.